Hello and welcome to our next video where we discuss eigenvalues and eigenvector. In my previous video you already saw the rank of matrix and how to solve the system of linear equation with the simultaneous equation with the help of matrix. Next video on matrix transformation is I am finding the eigenvalues and eigenvectors for corresponding system of equations, or we can say for corresponding matrix. So what is eigenvalue? Eigenvalue and eigenvector we have to speak. Another name is characteristics value and characteristics vector also. Sometimes they like find the characteristics value. It means both are same. Eigenvalue and characteristics value is same, that is called lambda. Eigenvalues are always in the constant form, means this lambda gives constant only. If we have this y is equal to ax is the system of equations function where y1 is a11 x1 plus a12 x2 plus up to, we consider this eigenvalues only for square matrix. So this is square matrix. Our y is corresponding function y1 y2 up to yn. A matrix is corresponding constant matrix a11 a12 13 1n an1 n2 nn, and x is corresponding vectors value x1 x2 up to xn. So this is, now we have to finding out one constant or one variable, means there are more than one variable constant values which satisfy this y is equal to lambda x. When we put this lambda, that satisfy the given equation, means ax equal to lambda x. X is an invariant vector, lambda is a scalar or called eigenvalues, where this x or we can say this x is corresponding non-zero vector for eigenvalue lambda. Okay, so this, with the help of this, we have to find out one characteristics equation, and that characteristic equation gives the value of eigenvalues, or we can say that equation, characteristic equations have roots. That roots are called characteristics values, or we can say eigenvalues. So some properties also have eigenvalues. So what are the properties I just discussed? Then we go for the problem how to find out the characteristic vectors and value both. So first one, how we represent? We know ax equal to lambda x for corresponding lambda that satisfy the function of y. It means if we say a minus of lambda is constant, so we multiply here unit matrix. So now it will become a matrix. So a minus lambda I x equal to 0, means if this is satisfied y is equal to ax, then lambda is one corresponding value which satisfies this regarding this vector, then a minus of lambda I into x gives 0. So this is system of n homogeneous equations. We consider or always remember, talk about the square matrix only. If number of rows and number of column are equal, then only we have to find out the values of eigenvalues and vectors. So our corresponding matrix, when we write this, a11 a12 up to a1n, a21 a22 2n an1 ann minus lambda of I is unit matrix of n order on. Lambda is lambda 1 into lambda 0 up to n variable 0, 0 lambda up to n variable 0, then 0 0, means diagonal elements all 1 multiplied with scalar lambda. So this is A matrix, this is lambda I matrix. So next our matrix becomes A minus of lambda I. So A minus lambda I means all diagonal elements multiply with lambda. This, because all other diagonal element minus with lambda and all other with A112 minus 0 means no change. So this matrix becomes A minus of lambda I. Now what is the next step for finding the characteristics equation? We have to find out the determinant. If this coefficient matrix is singular, if this coefficient matrix is singular, it means its determinant is equal to 0. So this coefficient matrix is 0. So we have to use the result that determinant of A minus lambda I equal to 0. With the help of this, we find out one equation in lambda. When we solve that equation, corresponding find out roots, then it gives the values of lambda, corresponding values of the lambda. Similarly, eigenvalue have some vectors also. What are the called vectors? So vectors is the one further step when you find out the values, eigenvalues. For example, for any 3 cross 3 matrix, you have to find out eigenvalues 1, 2, 3. Then we have to find out in each case vectors for lambda equal to 1. When you want to find out lambda equal to 1, you put everywhere lambda equal to 1. A11 minus 1, A12, A22 minus 1. This gives one new value. Then we can solve this system of equation with the help of reducing in echelon form or upper triangular matrix. When we reduce this echelon form, this system of equation y is equal to A minus lambda I, or we can say y is equal to A lambda, gives some value of corresponding x1, x2, x3, x4. That corresponding values of x is known as corresponding vector for lambda equal to A1 or lambda equal to A. Similarly, for second value, lambda equal to, if we have lambda equal to 2, for corresponding that value, eigenvalues, we have to find out one vector. For third value, we have to find out one more vector. So, if all eigenvalues are distinct, then there are corresponding and distinct linearly independent eigenvector. So, this is first property for eigenvalues. If lambda equal to A, B, C, if we have 3 cross 3 square matrix and lambda have 3 distinct values, so corresponding each value we find one vector. For lambda equal to A, our vector is x1. For lambda equal to B, our vector set is x2. For lambda equal to 3, x1 is, for example, something of x1, y1, z1. Second is x2, y2, z2. Third one is x3, y3 and z3. Means for, if all eigenvalues are different, then corresponding it have 3 linearly independent eigenvectors. Second one, if A is real eigenvalue or it's have complex conjugate, either lambda is equal to real value or it have conjugate complex, then some properties there it have to satisfy regarding lambda. Number 1, trace. You know what is the trace? Trace means sum of all diagonal elements. Trace is for any matrix. For example, we can say trace of A. A is our matrix. So, trace is sum of all diagonal elements of matrix A. It means if we have a 3 cross 3 matrix A11, A12, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3, 3 cross 3 matrix, then trace of A A is equal to sum of all diagonal, means these elements A11 plus A22 plus A33. Clear? So, but in case if we discuss regarding the eigenvalues, then for this, agar eigenvalues are lambda 1, lambda 2 and lambda 3, then trace is equal to lambda 1 plus lambda 2 plus lambda 3. So trace is always equal to corresponding eigenvalues. All eigenvalues, if n cross n, then trace of A is lambda 1 plus lambda 2 plus lambda 3 up to lambda n. Similarly, if we talk about the determinant of that matrix, if we talk about determinant, then determinants is also given by the corresponding eigenvalues. So determinant is product, trace is sum of, determinant is product of all eigenvalues. So determinant for this is lambda 1, lambda 2, lambda 3. Lambda 1 into lambda 2 into lambda 3. So you remember always in case of eigenvalues, trace is given by sum of that eigenvalues, determinant is given by multiplication of that eigenvalue, product of that eigenvalue. Similarly, one more property, if we can find out the transpose of given matrix A, then A and its transpose, A transpose, have same eigenvalues with diagonal elements are also same. Similarly, if we have a square matrix, we have to find out the eigenvalues and eigenvector. Then how to find out? Now I explain you with the help of one example, so you can better understand how to find out the values and corresponding vectors. Question is, find the eigenvalues and eigenvector of given matrix A 3 1 4 0 2 6 0 0 and 5. Step 1 is we have to find out the matrix A minus of lambda I. So A is this, minus of lambda I is 0 0 0 lambda 0 0 0 lambda. So this is A minus lambda I. So our A minus lambda I is 3 minus lambda 1 4 0 2 minus lambda 6 0 0 and 5 minus lambda. Now this is our A minus, step 1. Second step, find out determinant of A minus lambda I equal to 0. Using this relation, determinant is always equal to 0. When you find out this minus this, means your determinant is coming 3 minus lambda, 2 minus lambda, 5 minus lambda equal to 0. So this gives corresponding values are 3, 2 and 5. So we see here 3 distinct value for lambda is coming. So regarding these 3 distinct value, we have to find out set of 3 linearly independent vector. So now we go how to find out the vectors regarding these values. So this is very easy, just put the A minus lambda I, find out, then use the relation determinant of A minus lambda I equal to 0. When you take the determinant, find out the roots of given equation, it gives the value of lambda. Lambda is called eigenvalues. This is your eigenvalues. And corresponding vectors, now we have to find out. First corresponding vector for first value, lambda is equal to 3. So lambda is equal to 3, we have to put in our this matrix A minus lambda I. Here we put lambda equal to 3 everywhere. So this 3, 3 and 3. A minus lambda I x equal to 0. So 3 minus 3, lambda is equal to case 1, lambda is equal to 3 into x, y, z equal to, this is system of homogeneous, so 0, 0, 0. Clear? Now what is our matrix becomes? 3 minus 3 gives 0, this gives minus of 1, this gives 2. When we talk about the system of linear equation, there gives this last value. First equation is x is 0, this is corresponding x column, y and z. So x is 0x plus y plus 4z equal to 0. Second gives minus y plus 6z equal to 0. Third 2z equal to 0. So corresponding z equal to 0, it means z have some, z equal to 0 gives, when you substitute z equal to 0 here, then it gives y equal to 0. So z equal to 0, y equal to 0, x we don't have. So we consider x is any arbitrary constant k. So when we consider x is arbitrary constant, then corresponding eigenvectors x1 is, if we took k outside, then k multiplication of k with x is 1, y and z is regarding 0. So corresponding eigenvector for lambda equal to 3 is 1, 0, 0. If we put k is equal to 2, then 2, 0, 0, k equal to 3, 3, 0, 0, means with the help of changing the value of k, we have to find out many vectors. So general vector, if we want to write out in general form, k, 0, 0, or we can say 1, 0, 0. Second, we have to find out for lambda equal to 2. Second vector is for lambda equal to 2, we have to find out a minus 2i. I rewrite again. When we have to find out lambda equal to 3, 3 minus 2, 1, 4, 0, 2 minus 2, 6, 0, 0, 5 minus 2. So our this matrix reduced, 3 minus 2 gives 1, 2 minus 2 gives 0 and 5 minus 2 gives 3. Clear? In this case again, see 3z equal to 0, 6z equal to, means first equation gives x plus y plus 4z equal to 0, and with second and third we have to include coming that z equal to 0. If z equal to 0, then what is our y? Y is also, if z equal to 0, then with the help of this equation, x is equal to minus of y. Clear? Z is 0, x is equal to minus y. Again, if we consider x is equal to k, then corresponding y is minus of k and z is 0. So our next vector, eigenvector for x2, second eigenvector, for this is for lambda equal to 3, this is for lambda equal to 2, is k. If we k taking outside means k 1 minus 1 and 0. This is our second eigenvector regarding lambda is equal to 2. Last one is for lambda is equal to, our last root is 5. Now we have to find out for lambda is equal to 5. So our corresponding matrix is 3 minus 5 is minus 2, 2 minus 5 is minus 3, 5 minus 5 gives 0. So now corresponding equations we have to write. Minus 2x plus y plus 4z equal to 0. Minus 3x plus 6y, minus 3y plus 6z equal to 0, because x is 0. 0x minus 3y, this line gives x element, y element, z equal to 0. Last, z don't have value. It means we have to consider z is any arbitrary constant. If z is equal to k, then we solve this equation. 3y equal to 6z means y is equal to 2z. So y is equal to 2z. If z is equal to k, then y is equal to 2k. Similarly, now x is equal to y is equal to k, z is equal to 2k. Put here. We have to find out the value of x. 2x is equal to y plus 4z. So 2x is equal to y is 2k plus 4k. So 2x is equal to 6 of k. So x gives 3 of k. This is our corresponding vector for lambda equal to. So our third vector is lambda equal to 3. x3 gives 5k outside. X is equal to 3, 2, 1. So for all distinct lambda eigenvalue, we have to find out the 3 distinct linearly independent vectors. These are called vectors regarding corresponding values, lambda equal to 3, lambda equal to 2 and lambda equal to 5. So that's how we have to find out the value regarding lambda. Similarly, you can solve some more examples with same process. You definitely find out easily eigenvalues and then eigenvector for corresponding given matrix. Thank you very much.